Hello. So we are doing the sum to product formulas. We've done the product to sum formulas. I've got one of them written right here, the product to sum formula. And so if you've got a product to sum formula, you can obviously go backwards, right? When we think product to sum, we think, oh, I have the left-hand side. I'm going to turn it into this. But if those two things are equal, you can obviously go backwards, right? However, it's not the most convenient way to look at it, where the thing we're starting with, we have to split it up into alpha plus beta. It gives us a little bit of work to do. So what we're going to do is just do a little convenient algebra right now to make it easier to use this formula when we're going in the reverse direction. If we're starting with a sum, that will turn it into a product. And the way we're going to do that is the following. I'm going to define two things. I'm going to take alpha plus beta and call that A, and alpha minus beta and call that B. This means that A plus B over 2 is equal to alpha, and A minus B over 2 is equal to beta, right? So we can just quickly see this. If I take alpha A plus B, that's equal to alpha plus beta plus alpha minus beta. That gives me 2 alpha. Half of that is going to be alpha. And then alpha, or A minus B, gives me alpha plus beta minus alpha plus beta gives me 2 beta, and then we divide by 2 to get to those things. So with these relationships in mind, right, we're not really changing anything. There's nothing wrong with just naming alpha and beta their sum, right? This is some angle in here, and this is some other angle in there. So I've just given them names. And then based on those names, we get these other relationships. With these things in mind, I can rewrite this equation. Sine of, instead of alpha, I get A plus B over 2. Cosine of beta, that's A minus B over 2, equals 1/2 sine of A plus sine of B, right? So I've just used those two relationships to rewrite this thing. And then I'm going to multiply that 1/2. I'm going to multiply both sides by 2. And I'm just going to reverse the order. So if I multiply everything by 2, and I'm going to switch sides here, we get sine of A plus sine of B is equal to 2 sine of A plus B over 2 cosine of A minus B over 2, right? So this is really the same formula. I mean, we really have done very little here. This was sine of A plus B over 2. It's really the same formula, right? We've moved this 1/2 or factor of 2 between the sides, and we've just expressed the relationships between the angles a little differently. And the whole point of that is, if we're starting with the sum of angles, we're going to be staring at the angles A and B. And now it's easy to know what to make the two angles inside the sine and the cosine over here, right? If we didn't have this formula and I was giving you something like if we had sine of 30 degrees plus sine of 60 degrees, you'd have to figure out what alpha and beta are, and then using those two numbers. And that would just give you a little bit of extra work to do. We've done the work already so that it's simple to use. And we can play the same trick with all of those product to sum formulas to get the sum to product formula. So let me list them all now, and then we'll do one example. We're doing the sum to product. And there's 4 of them, just like the other ones. So we've got sine of A plus sine of B is equal to 2 sine A plus B over 2 cosine A minus B over 2. And then we get sine of A minus sine of B is going to be equal to 2 sine A minus B over 2 cosine A plus B over 2. And let's see, then we have a sum of cosines. We'll have cosine of A plus cosine of B. This is going to be equal to 2 cosine of A plus B over 2 times cosine of A minus B over 2. And then finally, cosine of A minus cosine of B, we will have negative 2 sine of A plus B over 2 sine of A minus B over 2. Okay, did I transcribe these right? I believe I have. So there are our 4 sum to product formulas, right? I got them in the same way. If you go back to the product to sum formulas and make the changes I made with A and B, you can derive all of these formulas, okay? And they're just convenient to have in this formula. And we'll just do one really brief example to finish this video. So for instance, if I had something like cosine, I'll do degrees since I never do degrees, cosine of 15 degrees minus cosine of 75 degrees. Right, so I'm looking at this last formula. I get negative 2 sine of the sum of those 2 angles. So that's 15 degrees plus 75 degrees, or 90 degrees divided by 2. Sine of, and now I'll subtract them. 15 minus 75 gives me negative, divided by 2 gives me negative, well, let's write it out. Just be consistent since I have the 90 over 2. We get negative, what did I say? 15 minus 75 is negative 60 degrees over 2. This gives me, let's use a property of sine here. The negative can be taken out front. Remember, sine of negative theta is equal to negative sine theta. In other words, we get a factor of -1, and it'll cancel that negative out front. That makes this easier to deal with. I get 2 sine of 45 degrees, sine of 30 degrees, which is 2. The sine of 45 degrees, sine of pi over 4, root 2 over 2. Sine of 30 degrees is the sine of pi over 6, or 1/2. Looks like we are getting root 2 over 2. Okay, and again, just like in all the other videos I'll mention, this isn't really the point of these to compute. I mean, it doesn't hurt. It might come up now and again, but we'll do some solving of equations, some other kinds of manipulations and things like that, which is like where the real power in this stuff comes from, or when you get later to calculus or other science classes, or you have to do things like integrals and derivatives. It might be convenient to be able to switch the form of the function you're looking at, because certain operations turn out to be easier when we're doing products or sums or those reduction formulas and all of these. Okay, that's it for this one. Thank you, everybody. I will see you next time.